right, well, today we're back to work on the NASCAR swap Miata build, and we are on to the most critical part, really, of the entire build. This is what everything else is going to fall in line around. If we get this right, we will be on easy street, building other parts of the car. If we get it wrong, we're gonna be on the struggle bus to struggle street. So we gotta do this right. This really, again, this is the backbone of the car, and that is mounting our drivetrain. So we've got it in here. We've got our early 2000s Dodge NASCAR motor. We've got our NASCAR 4-speed dog box race transmission. It's all in here and it fits, bell housing and everything, but it's not mounted. It's not as simple as making a conversion motor mount, because we're not gonna be motor mounting this like our LS was, with just a mount and a mount to the block. We're using a motor plate, mid plate combination. So we're gonna be mounting the motor at the front, mounting it at the back. We are also going to be mounting the transmission, but really the transmission mount's a formality when you have a motor mid-plate combination. Now the thing is, a 97 Miata was never designed to have an 800 horsepower, 9,000 RPM, fire-breathing NASCAR motor shoved in it, but definitely not with a mounting structure in the middle. So we've got to completely build out our structure to mount the mid plate to. And again, that's kind of the backbone of everything else and supporting the engine. And then once we get it structurally done, we've got to cover all this back up, all this new stuff that's a little bit different size and shape than the old stuff, while making sure we account for the other things that come down the line. So I mean, when I say if we do this right, it'll be easier later on, things like the pedals. So that being said, a lot of this stuff, it's like we're paying the interest up front on the build, in the sense that the chassis work is some of the most complicated stuff we have to do. At least, who knows, ask me sometime when we get to the other stuff if I still believe that. But to do some of this stuff, we've got to make some new tools. It's, you know, new territory. So I've got some material here. I've got some plans to make some new tools for this specific project that should make our lives easier and make for a better finished product. So gotta have tools to build the parts, gotta have parts to build the car. So tools, then we can do parts, then we can do car. We got everything we need to do all three, so only thing standing in our way is me, jibber jabbering. All right, guys, well, before we get too deep into today's video, I want to talk to you about today's video sponsor, Sunday. Now, I'm a skeptic when it comes to products. Like, for me, seeing's believing. I got to see it work. You know, I have a hard time believing stuff without seeing it firsthand for myself. And with Sunday, what sold me to just try it without seeing yet was the convenience factor. You know, you put in your property information, it pulls all the data, figures out kind of the perfect custom lawn plan for you, which A, takes the guesswork out for me, B, gives me a regimen to follow so I don't forget, you know? But what really has sold me is the results the last time I did my regimen, phenomenal, right? But you could count them maybe as a fluke, you know? I'm skeptical, right? But this time, I started my regimen again 3 weeks ago after fixing up all my property stuff. And in 3 weeks, the results, the change before and after is insane. Just in general, but then especially considering the fact that this entire time we've been in a drought, a major drought. We have had not a drop of rain in those 3 weeks, and the temperature has gotten hotter. So if anything, we should be losing grass right now. Everyone around me seems to be losing grass, and we're gaining grass, which is just so crazy. And after seeing and believing, it makes sense, right? The liquid package, you're spraying water onto your grass with the fertilizer in it. The grass is going to take in the water. It's, you know, it's what plants crave. Some of you will get that reference. And it's got the fertilizer mixed into it. So it's just straight to the grass, taking it, no middleman. So it makes sense, and you get a lot more fertilizerability, whatever you'd want to call that, and a smaller package. It's very dense. So I could go on and on. I could jibber jabber on and on about this. I'm so stoked to finally have green grass again. But if you're interested in trying it out for yourself, whether you're maintaining your current lawn, that's good, or you're like me, maybe you slacked. I mean, I did not give this much to start with, but it surprised me, just like it did last time. So if you're interested in trying it, go to getsunday.com/TaylorA with 2 R's and use code TaylorA30 to get 30% off your first custom lawn plan. It's a great deal, so you can just try it out. If you're like me, you're a skeptic, firsthand, see for yourself how well it works. And I can almost guarantee you are going to be a believer as well. So that being said, speaking of analyzing and thinking, we got a lot to think about, design, come up with, create to build this car. And I'm trying to build this car, so let's get back to that. All right, well, that's one done. Probably didn't need to fully weld it all the way down, but after what happened to this one, I just wanted to cover my bases. Granted, this thing lasted like 4 or 5 years of some seriously heavy bending before it let go, and this is kind of V2 of this design. I just whipped this up quickly because I needed it for a project 4 or 5 years ago, you know, and then it's one of those things where it just worked, so I just left it. I never bothered messing with it again. I remember thinking that I probably wanted to do something, but anyway, so V2, what we're doing with all of these is basically a support tube underneath. So all that load's pushed down in there, and then the flat bar is basically just supporting the lip. So that's what we're gonna do when we redo this one as well. And we're gonna do a larger one for when we're bending really heavy wall stuff, like thick 1/4-inch plate, stuff like that, where it would help us to open up the radius a little bit. That way now we'll have all the options, so. Anyway, one done. So that's exciting. There's 3 tools I use in the shop more than really any other tools, and that's the belt grinder, the bandsaw, and the press brake, the bender. And this die that I had that broke was the one I pretty much left in there all the time. So that one absolutely needed to get rebuilt because it's used on a pretty regular basis. But we also needed some specialty ones for this project. So that's basically the goal here, is to build at least the main options that we could possibly need for all the different types of projects we do. So this second one is for thick material. I had some problems. That's how I broke the last one, is trying to bend 1/4-inch plate on such a small tight radius. It's a lot of load, and it's hard to get that thick of material to make that tight of a bend because the material is as thick as effectively the bend radius. So this one should give us the option to have an ability to bend that thick material, which isn't something I'm doing a ton of, at least not at the moment. But it is one of those things. A lot of these tools, it's if you need it, you might not need it all the time. But when you need it, there is no substitute. So we're just having a press brake die bending manufacturing die combo party. So we got the thick one done. And now it's a matter of really the main one, the one that I use all the time, and that is this thin, tight radius one. This allows you to get complex bends really close together when you're doing a bracket with multiple bends, and that is what we're doing most of the time. All right, well, I was debating this. Flat bar, because of that tube I used, is tucked in a bit. So obviously we'll weld this. It'll have strength. I'm just worried about mushrooming over the edge over time. But the flip side is the narrower we keep this, the tighter we can get our bends together. So I think I'm gonna run with it. Let it ride. See here, this one, I welded the flat bar basically butted up against it. So I mean, you're talking about at least a solid 1/4-inch wider overall. This one fits in here nice as well. Boom. Pretty happy with that. These are all coming out nice. I just gotta weld this one up now that I'm committed to it. Redoing this die, it's almost like it's kind of a good thing that the other one broke, because I don't know that I would have gotten around to doing any one of these. Probably at least the wide radius one, because that one we specifically need for this project we're working on the Miata. But this one, you know, it's always been something I wanted to upgrade, but yeah, it ain't broke, don't fix it. But then it broke, so then we could fix it and upgrade it. And it's just always, every time the second time around you do something, it's generally turns out a lot better because you've learned from the first one what worked, what didn't. And there was some things about that first one, specifically the flat bar being on the outside, that always was kind of a pain. So now we've resolved that. It's stronger, it's stouter, and we can get our bends tighter. Win, win, win. Old versus new. Much cleaner. All in all, man, that came out pretty dang nice, gotta say. A lot of welding. Hot welding, but welded. All right, well, we've got all 3 done. So this is our new main squeeze here. Pretty stoked on this, excited to use this one. We've got our old one, wow, so much lighter. Old broken Johnny. But you can see just how much narrower this one is. We've got our wider radius, thick material, and our round one. So So we got to do it. We got to try them out. We got to know what we're working with, you know, before we use it on the project. Don't need any surprises. All right, which one do you guys want to try first? Let's try the big one first. I asked you, and then just because I've already got this somewhat adjusted. Use this to center it. Gotta turn the compressor on. Alright, we're gonna try it on some 1/4 inch scrap. Well, you know, this is literally basically exactly what we broke the last one on. Oh, perfect. Look at that. Perfect 90. Nice. Try something thin. You'll see when we switch to the smaller one how much tighter of a radius that is. It's a pretty wide radius. Let's try. Lastly, let's try some 1/8 inch. This is what I've been most of the time, which I would probably be using the tighter radius one, but just to see. Spinning really nice and even though, for sure. Oh yeah. Nice even bend. But yeah, you can see how wide that is. Like if you're making a tight back-to-back bracket, that's a little bit wide of a radius. All right, now let's try the tight radius. All right, same combo of pieces and 16 gauge plate. One thing with this die, like the old one, is it's very easy to overbend. So you can see how tight that radius is. It's a lot tighter. It'll be a little more pronounced on this too. It's interesting too. You can see how much faster it makes the bend because it's tighter radius. Oh yeah, see that's way tighter. All right, time for the last one. Main reason we did all this. All right, piece with no holes first. Should have put one more of those here. I might do that later. Is that? Oh, I over 90'd it. Because you could 180 it with this, so we're gonna have to be careful with that. Oh, there we go. And there's our 90. Smooth radius. Yeah, see, like for a transmission tunnel, that's money. So you can see the 3 different radiuses. Radii. Tight, middle, widest. You can see it kind of well here. See how much tighter that bend is? That's the tight one compared to the wide one. Pretty stoked on this. All the new dies. This one we can scrap. Let's just straight to it. Perfect timing. All right, I'm gonna add that support and then let's get back to work. So this part of the project is the one that's given me the most thought. The one that I've mulled over a bunch of times trying to think of the best way to do it. Now, it's not that any way to do it is hard to find. There's 100 different ways we could do this. We could mount this mid plate and then build this transmission tunnel structure. It's not about that. It's more so what is the best way to do it, or what's the closest to the best way to do it, or what's the best way that we have the tools and capability to do it. So I came up with kind of a rough game plan to build effectively a bulkhead at the front to start our transmission tunnel from. So we're not going to this firewall with a bunch of undulations in it, and basically just need to design it based off all the dimensions of what we've got for the tunnel there. And it would be dual purpose to where we can not only build the tunnel structure from that tunnel covering, the sheet metal, but also we can use this to mount our mid plate. So it's a mid plate structure, basically tying everything into the frame. And that would work well, hopefully, but we won't really know until we try it. So I got the rough design done and then save that just in case I wanted to do things differently, and then went through and, just rounded off all the corners and I want to go ahead and add a bunch of holes so we can dimple die this, because this whole project, the goal is to save weight. And I will say it's kind of against my instinct. I'm definitely the type of person that's, oh, what's half a pound here? What's, a quarter pound there? It's not that big of a deal, but it is a big deal when you add that up over hundreds of pieces. So we've got to be diligent on every single one of these and find any way we can to make them lighter. And yeah, lots of dimple dies will help in that direction. I do not remember what I got this sheet for, and I'm kind of afraid to use it without remembering what I got it for. But it's exactly what we need, so we gotta use it, because this drawing is right on kind of the max size that we can cut on the arc droid here. So we needed a big piece so that we could get it centered kind of exactly where we wanted, and that's definitely always a fine line to toe, but hopefully we can get this to cut out nice, and it works like we're hoping. Only one way to find out. I'm gonna have to make some revisions. So unfortunately, the design is just a touch too wide to go in without cutting more of the tunnel out, and I want to make it to where it can go in a little bit easier. So we need to revise it. Now, it's not all wasted material. It is a bummer when you cut something and it doesn't work, but the benefit is we can use it as kind of a template and to mock up different ideas. So if we stay with this direction, it's a lot easier using an actual piece of material than cardboard or your imagination, So I wanted to go ahead and throw some dimple dies in it so I could see how those played out. That was kind of conflicted on if they were going to work out for this location or not. Problem is, when you have the press brake set up to bend, you have to take the whole thing apart, readjust everything in order to press something like a dimple die. So I decided to make, while we're in the tool making mode, make this little bracket that could go on there on the top, and then as well as a piece on the bottom to go in between the slats. So that way we have a press spot where we can at least press thin stuff without having to take it all back apart. We can just switch back and forth easily, because a lot of times we're doing both at the same time. Okay, I mean, it works. Look at that. But kind of forced it right off. Yeah, that worked. That size worked. It's a good thing I didn't go larger. I was planning on doing 3/4 inch. And I'm gonna fix this real quick. All right, sweet. That seems to work. If you want to take it off, thread it out. I thread it out. And then this is threaded. So the bolt stays with it. I really just need a couple for determining offsets. So let's go mock it up in there and see what changes we need to make for V2. If you can even call it that. I mean, that's kind of what I was going for. I think we need to move it up, but there's a couple problems with this design method. If we make it strong enough, it's gonna be bulky. Firewall's double thick. It's honestly plenty strong for what we're doing if we wanna go straight to it. We can weld in plates the same. I've got a plan for that. The other problem with doing it this way is if we have a fixed structure here that the mid plate bolts to, then we can't pull the bell housing out backwards. The only way to pull the bell housing out would be to pull the entire engine out. We could do it, but if we have a throwout bearing or something go out at the track, even if it's easy, I still don't want to have to pull the whole engine out in the pits. I'd much rather be able to just pull the bell housing out. Point is, we can't make a fixed structure for it to bolt to here. So what I want to do instead is basically build a bracket that bolts into the frame rail here. So if we were gonna pull it out forward, we just unbolt it here as if it was a fixed structure. But if we wanna pull it out this way, we can remove it from down there and pull the bow housing out backwards. But I think to do the mid-plate mount right, make it plenty strong enough, but also light and compact, we're gonna need to basically machine one, build aluminum. We're gonna have to go ahead and hit the commit button on cutting the rest of the tunnel out. All right, well, 15 minutes. Obviously that's without a bunch of stuff hooked to it, but it comes out pretty easy. Such a nice sight to see this thing complete. Okay, my plan, looking at going back to here, I need to do some measuring. Maybe we'll just go to here in case we decide to do a different shifter offset. The way I try to sit in the car, I try to get myself as far back as possible. So let me do some measuring, and then let's get to cutting. With the tunnel cut back to where I want to build from, we need to get this cleaned up and ready to be welded to, so that if we're happy with the location and everything's gonna work out, we're ready to weld. We don't have to go back and do this again, especially once the engine's back in. One of the least fun projects when it comes to building a race car out of a street car chassis is getting rid of the sound deadening. And admittedly, I haven't done much of that because, as I mentioned, I was the, a pound here, a pound there, doesn't really matter kind of guy. So I left all of it in this car. And this situation, we need to remove this off the firewall. It's equally about weight as it is about having clean material to work with, because we're going to be building to this, and even if we're not welding directly to this spot, if we're welding anywhere near it, it's just going to set on fire and smoke and be just an absolute mess. There's nothing worse than trying to TIG weld in a tight area and just having something burning off in your face. Toxic fumes, not a good time. All the dust and grinder stuff on the inside, as well as all that sound deadening, and there's some weight there. I mean, there's some weight. I don't know how much, but it's there. Weight, race car. All right, well, man, we definitely got a lot, but I mean, that was the plan from the start. We're gonna be cutting more. We're gonna be cutting the frame rails out here and the floors because they are pretty cooked. As you can see, I welded in plates at some point because the floor started ripping apart from the seat mounts, but we have our clearance now. Clearance. We have our clearance. So yeah, we can, I should cut this freaking e-brake pocket out, huh? Because I think it does get in the way a little bit of getting everything squared up. Thought I was done with the cutting. Yeah, I'm gonna cut this out. All right, well now, now we can say we're done cutting, at least as far as I know. There could be more cutting that needs to be done, but for all the cutting I had intended to do, it is all cut. With the exception of, one thing, I'm not gonna worry too much about getting the rest of this goop off of here because we may be rebuilding that for clearance for the distributor anyway, so no point in wasting a ton of time trying to get it perfectly clean if I'm just gonna hack it out anyway. So for my plans, for what I know, we are cut. We are ready to go. We have point A, point B, or point A, point B, however you want to look at it. Bob it. Yeah, and obviously it's a pretty massive hole that we got going on there. We definitely got our work cut out for us. Oh, the puns. Not intentional, but to fill this back in a way that makes sense. Now, something I want to do here specifically that I haven't done on other builds is I don't want to do it like stock, where the transmission tunnel sheet metal is also the structure. We're gonna build our own structure independent of the metal, the sheet metal, and then have our sheet metal covering, and that way we can remove it. I want it to be removable because this is like one of the more difficult areas usually to work on a car because you got a lot going on in there. I mean, even with a small transmission like the dog box, you still got that. You've got the exhaust going through, starter, lines, fittings, there's a lot going on. And especially in a small car like a Miata, it can get pretty tricky. If we can remove this whole top section and have access from the top and the bottom, it will open up a whole world of possibilities and simplicity when it comes to working on this thing. And that is one of the main goals, is making this thing as easy to work on as possible. That was my goal in the vet, and it's not bad, but I mean, it's a big single turbo LS. You can only make it so easy to work on, Vets default are not easy to work on. So the goal with this, easy. I want to be able to take this whole car apart in a day, chilling, So anyway, I've got a rough game plan of how I want to do it, but we got to get the old drivetrain back in so that we have kind of our dimensions to build around. Make sure we don't box ourselves in anywhere. So we can come up with as far as a tunnel. This is definitely, at least as far as I know, maybe we go down more rabbit holes and there's something more complicated. This is going to be the most complicated part of the build and one of the most important. So if we get this right, we're in good shape, you know what I'm saying? One thing that's kind of challenging is I'm trying not to hack up this subframe. I'd like to save this subframe so if someone else could use it in an LS swap Miata. But the motor mount situation is in the way. I plan on rebuilding another subframe for this car, but this one works for mock-up. So the dry sump has to come off in order to get us that clearance that we need to put this engine where we want it. We need to play around with a few more spots. We're kind of limited to where it was before, which wasn't quite center and wasn't quite exact because of the dry sump hitting the motor mount as well as the steering rack mount. So if we're gonna build to it, we got to make sure it's right. When you're building a car like this, where you're swapping an engine that may or may not have ever been swapped into a given chassis, and you're building around certain parameters. This is a drift car, so it needs to do certain things. It needs to have certain types of suspension. All of those things are factors, but there's kind of two really big things that are difficult for us when it comes to putting this engine in and getting it where we want it, and we got to decide where we want to compromise to make it work. And this is the time where we gotta start making those compromises or deciding which ones to take. So along with building the transmission tunnel, we have kind of two major things that we have to account for in this stage of the process. If we don't, we will very much regret it later. One of those things being the steering rack. So the stock Miata racks are pretty hard to find in manual. Mine wasn't even a manual because it was an MD rack. It never came manual, so it was depowered. But it's a pretty bulky rack because it's meant to be powered in a stock car and all that. And fitting it under this, but not too far down, tricky. However, it dawned on us one day that this Pinto rack that we have for the RX-7 might work well in this scenario. It's very compact. They're affordable. They're really, really easy to get a hold of. Oh yeah, that is for sure gonna work. Oh, well that's with this engine height. I really want to bring the engine down some. And that's where it might get a little bit tricky. I think we could bring the engine down that 1 inch. Obviously we're gonna be building it around this rack, so this rack's kinda gotta work, but I don't see why it wouldn't, because this is designed from the factory as a manual rack, you know, and we run manual steering on this car because it's so much simpler than dealing with power steering problems. But yeah, so I put this 1-inch block of wood in here, and now it's a little higher than I want. So I'm gonna drop it back down, I'm gonna pull this wood out, see how this mocks up without the wood. If it looks like we can make it work, then we can party on building our tunnel around this engine, the engine at this height. I think either way we're going to be able to make this work. Might take a little willpower, but that's what we're here for. All right, moving on. All right, so the next thing that is going to be seriously tricky with this is our pedal situation. I got to put the seat back in so we can mock this up. The Miata is a small car. I don't know if I mentioned that before, but no, it is though, and it means we're kind of limited on how much space we have. So we've kind of got to pick and choose and take a little from here to give a little there. So the more we give to the transmission tunnel area, the less we have for the pedal area. And as you can see, with how far we have this cut, it's there's not a whole lot of room left for the pedals here. Not a lot of room left. Now, there's a couple ways around this. One would be to kind of bring the tunnel in tighter. Two, it's to redo the cage. The cage lands on the floor, so it takes up this whole chunk of space. So we could land this down bar on the rocker, which would really be a better spot anyway, and get all this space back. We could even do both, you know, but I want to see how much room we have as is if we were to leave the tunnel this wide the whole way. The only way to find out is to mock the pedals up in here. And I've got a pretty slick setup for the pedals, and I'm excited about it. I had this old setup that came with the old vet chassis, full hanging. It's all right, but the cylinders are on the backside, so it won't fit. So I got this is pretty standard stuff, pretty standard drift car build stuff, wood hanging pedal setup. This part is pretty neat, something I've wanted to do for a long time. Not only is it a billet floor mounted pedal, but it uses a linkage system. So we got basically this setup with the two levers, the linkages, and if we can make this work and all of this fit in there, this would give us a direct throttle connection. So fully linkage, no cables whatsoever. All mechanical linkage, which obviously a lot more robust, a lot more reliable, a lot crisper. You don't have that slack and slop in the cable. It would just be awesome if we can make it work. I don't know if we can though. It's gonna be a little tight. I don't know if I mentioned it, but the Miata is a small car, so. Oh yeah, that's totally fine. That's actually pretty much perfect right there on the flat. Shoot, even with that, we wouldn't have to redo the cage. Oh, that's gonna be nice, dude, nice. Yeah, I mean, either way, they're far enough forward to where we can get around this bar and still keep them far enough apart. Okay, that's all I need to know. With the pedal debate settled, I mean, the cage redo is still an open-ended question, but I wanted to at least make sure we could leave it if we decided to leave it with where we're mounting the pedal, because where we mount the pedal determines how we build the transmission tunnel. The other thing I wanted to see is if this linkage system is even going to work in here with where I would need to mount it, which is up above the tunnel on the dash bar. And after some messing with it and trying out different linkage links, I think it's gonna work. I think it will actually work, being able to go up on that bar and then go through the firewall. Whether we can get a throttle body to work with it, we'll make something work. I say whether. I mean, we'll figure something out. But now we've got the pedal location at least, so we can kind of build the tunnel up to it, make sure we give ourselves some space. And basically, we just need to trace over this, the area where we're going to be starting from on the tunnel. That way we have a nice template to use with all of our angles and dimensions. So it'll make this part of the process a lot easier than trying to figure it out as we go. All right, well, this is not gonna work like I wanted. I wanted to do this piece, our kind of bulkhead piece that the tubing will come from to go to the firewall out of a piece of this 3/4 inch chromoly. The problem is I've only got about 4 inches between that bend and 4 inches between this bin. With this center line radius and our offset, we need 6 1/4 between. It's not gonna work. Anyway, so 2 options. A, we do what we were gonna do on the firewall for the tubes to land on. The problem is that's gonna take up a lot of space. The other thing I was gonna do is make just a little like triangle, like a plate that goes, but then also slopes down. So I'd weld those in on the underside, and then the tube could land there, which also is not a bad idea either. Maybe I'll design both. I don't know. While we're there, though, designing and plasma cutting, we actually have another shop thing we need to design. I got a bunch of new TIG rod holders because I've got a whole bunch of new TIG rod coming in. I've been pretty limited on my options. There's sizes and types that I don't have that I need. I just got all 3 sizes of silicon bronze because we're gonna wanna use this for the sheet metal to chromoly if we can. Anyway, we need more tubes, which is why I got more tubes. So I wanna not only make a holder for those to go on the table, but I wanna replace this one because this one I made a long time ago. It's kind of quick and it's got no bracing. The holes are too big, so they just slide in. So sometimes when you can't get it to thread off. So I'd like to make the holes where basically that slots in and locates them so you can take the top on or off without having to hold the bottom side. And I'm gonna label them because we're gonna need all those different TIG rods between, really even just with this project, we're gonna need pretty much every single one of them, but also especially between this one and the RX-7, all the fab work we gotta do on both of them, we're gonna need all the options. So it'd be nice to get that set up now. And while we're plasma cutting and making a mess, might as well get that done too. So let's get to it. We got a lot of designing to do. So usually when I'm designing something on Fusion for sheet metal, I just design it in 2D because it's kind of simpler than having to learn the sheet metal function. But for this, we're doing more and more of this sheet metal stuff. So I decided to take the extra time, which designing stuff already takes a bit of time, and try to learn how to do it in the sheet metal function, which will make our lives a little bit easier because it will account for all those bin diameters and things like that based off of our materials. So I started cutting out the TIG rod holder first, just because it was going to take up a lot of space, and the brackets not so much. And it cut out really nice, but I wasn't a huge fan of it, so we shelved that for now and need to cut out our stanchion brackets. If this works like it is in my head, it would be a good way to do this, but anything we're gonna do here, I feel like it's going to take up a lot of space. So that's what I'm worried about. You gotta see it though. You know, sometimes you think something's not gonna work and it works, and sometimes you think things are gonna work and they don't work. So making these brackets will at least get an idea of how this design and this concept would work. Now, obviously they aren't perfect. There's definitely some revisions that need to be made, but the rough concept is there to see if this is how we wanna do it. I actually don't dislike this as much as I thought I might, but basically this is the idea here. You know, let's say you put it there. It obviously needs some refinement, but you know, there or say there. And then the tube can slide in here, which gives it some misalignment, so we can kind of angle it, move it around, plug weld it there, and then this would be welded in, distribute the load a lot better of that bar, and give it a nice end cap. The thing I worry about is that being so close to the transmission, I fear that these are going to kind of get in the way when it comes to pulling the transmission out and putting it back in, especially because we really need to bring the tunnel up a bit. So now I'm toying with the idea of cutting all the way back to this seam here. The only thing in that area would be the drive shaft and then lines, which we could even make provisions for lines to pass through to give them a nice spot to mount to as well. So I'm gonna mull that over. In the meantime, I have redesigned our TIG rod holder. I gotta say, I'm super happy with this one. It came out so much better. I mean, that's usually how it goes. You know, with anything you do the second time, you kind of figure out those odds and ends and whatever, but I'm real pleased with this. Getting the nubs designed in, it was a lot cleaner, so hopefully we shouldn't have any weird cut things. And one thing, I decided to do one thing differently. Well, I guess actually the whole design's different, but aside from that, I'm gonna cut it out of aluminum. And if anything, if it comes out nice, we can even go so far as to polish it up, you know, which would be pretty satisfying. So while we mull over our can of worms rabbit hole combo here, let's get this done. we'll figure out the rest. That cuts so good. Look at that. There's almost no slag whatsoever. I would say 1/8 inch aluminum is probably the material I've used more than anything else when it comes to making anything that you would use plate for. And this is actually, though, my first time cutting it on the plasma table. So I'm really happy that the cut settings worked out, because I just kind of took a swing at them. I wasn't sure because I haven't cut it on here before, and it worked out. The plasma cutter did its job. Some of the best cuts I've ever got out of that. However, we're not through the finish line yet on making these. Had some struggles with the steel, and the bending's really the make it or break it part, and I may have broke it a little bit. Irony, pun, because it's a metal brake, but Fusion had a set for the bend lines, and my markings weren't quite, I think, where Fusion wanted them, but luckily we have the ability to take off different parts of the finger brake here to bend in these box corners, assuming you don't smash your hand into the the jack base like I did. But it allows us to do this 4-corner method here, and I don't think I've really ever had one where it actually worked out, because usually the pieces there's one piece that's too long and smashes into the bender, so you can't complete the bend, and I normally avoid doing it like this, but I was hoping we could make it work on this one because of the dimensions, and it worked out. They're not perfect. I definitely could have done my job a little better, but hey, you know, they're nice, they're shiny, they're stout, they're rigid. That's why I like making things out of 1/8 inch aluminum. It's one of my favorite materials to use. Now, the one tricky part here is these tubes, while they have those slots that we're using to locate them so we can screw them in and unscrew them, they don't have them all the way to the bottom. So the bottom's just round, so it will not go in unless we basically extend those grooves down to the bottom so we can get them started, which is a bit of a messy job, but small price to pay. It's definitely messy, but we now have a metric ton of TIG rod holders. So when the rest of our new rod gets here, we can go through and organize it all. They all do what was intended, where you can tighten them up, take it loose. Jibber jabber, that's done. Like I said, I got a little messy there. I haven't come to a decision on this transmission tunnel. I need some input, some insight, because again, there's a couple ways we go about it. We could stick with this plan of working it from here, doing those little stanchions, which I think we'll end up using something like that for the seat mounts that are going to go underneath when we do the new floor. But I think probably best to either at least cut back to this seam, or maybe even cut all the way back to the firewall, do a plate, and then we have a nice, fresh, flat base to start with. The other thing is the cage. There's redoing it. It's a good cage. It's a nice cage. It's all TIG welded. It's just, there's specific Miata things you can do when building a cage. Like we can go to this rear shelf here instead. So that would put the down bars all the way back here, which would mean we could move our passenger seat back. The passenger seat is rough in this car. It's always kind of too high and too far forward. We could get these tucked further over so we can get this seat further over to kind of better accommodate where our pedals and stuff are gonna have to be. We could get this bar out and up some, because I consistently bump my head into it, which is part of why we are dropping the floors down to get the seat lower. We could bring this bar to the rocker so we can get that out of the way. You can also see witness marks from my foot rubbing on that. So we could just get ourselves a little bit more space if we really maxed out where we could put this cage. And you know, the more space in a car, the better. We could also make it out of chromoly to make it significantly lighter. So kind of a win-win there, you know? Because chromoly is expensive, but it's, to do a cage, even if you account for messing up like a whole bar, it's not crazy. You know, it'd be less than $1,000 in cage materials or so, something like that. I'd have to redo the math, but it's not insane, you know, if we're doing it ourselves. So whole goal's lightweight. I don't know. Let me know what you think on that and the transmission tunnel. I need some input before we go cutting anymore, because I've already cut a bunch of stuff out. We've been going a little cut crazy. I said this when we started this, that you got to be careful not to go cut crazy, and here we are going cut crazy. But you know, it's part of it. every time you peel back a layer of the onion, you know, you find some more, and if I peel back a little bit more, can make it a little better. And obviously the more you peel it, the more work you got to rebuild it, but the better it can be potentially. So we're out of time, unfortunately. So much more I wanted to do. I got some boxes over here of parts for this thing that are really exciting that I haven't even looked at myself yet. We got a lot to do next time, but for now we are out of time. We are flat out of time. So I'm gonna go ahead and end it here, but thank you guys for watching. Thanks for subscribing. Yeah, I'm excited for the next one. We're gonna start rebuilding this tunnel, so I need your input ASAP. So let me know in the comments. That way I know, help give me ideas on what direction to go before it's too late. So, you know what I'm saying? So anyway, I'll see you guys for the next one, but for now that's it. Thanks for watching. Thanks for subscribing. Goodbye.